Now this is our next question. Question number 22. It states that the table refers to the hydrogen halides. Which row is correct? So going down the group, the oxidation of the halides, we have to discuss about the oxidation of the halides. We know halides belongs are considered as fluorides, and then chloride, bromide, and iodide. These are the ions present in the group number 7. So down the group, the oxidation of iodide is more easier as compared to the oxidation of the fluoride. It is difficult to be oxidized since fluoride can oxidize all the other halide ions. Difficult, whereas iodide is very easy to be oxidized. So in this case, the option A and option C are the right ones. Now about the thermal stability. They are asking about the thermal stability of the hydrogen halides. We know hydrogen halides means the bonding between hydrogen and the halogen. So if we move down the group, the size of the halogens increases. If it is fluorine, then at the bottom the iodine will be very large size. So overlapping of the atoms will be smaller, and smaller overlapping or weaker overlapping leads to a weaker bond strength. So bond strength is weaker in case of Hi. The Hi bond is weak, and so it can easily be decomposed by applying the heat. So here the thermal stability decreases down the group. So the only correct option in this case becomes C option with 2 ticks. Now question number 23. Question number 23 says 7.5 gram of nitrogen monoxide reacts with 7.0 gram of the carbon monoxide on the surface of the catalytic converter in the exhaust of the car. What is the total volume of the product gases measured at room temperature condition? So we have to know the reaction between the nitrogen oxide, the nitrogen monoxide reaction. We need to have clear idea about the reaction of nitrogen monoxide with carbon monoxide. Only then we will be able to uh, get the answer of this question. So for this purpose, I will show you my notes. In my notes, you can see here that inside of catalytic converter, the reaction between nitrogen monoxide and CO is this reaction. This is a reaction inside the catalytic converter between these two substances, 2CO, 2NO to produce 2CO2 and N2. So we need to have this reaction written here. So I will write 2CO plus 2NO will produce 2CO2 and N2. After this, we have to do some calculations. The question says that volume of the product gases. The product gases here are CO2 and the N2. CO2 and N2 are the product gases here. Okay. Then next we will put the values here. We have 7.0 gram for CO. We have 7.5 gram of the NO. Then after that, we must convert them. The masses must be converted into the moles. These are the masses. The MR value for carbon monoxide is 28. For NO, it is 30. Then we calculate the moles. The moles will become for carbon monoxide is 0.25 and for NO it is 0.25. Since both are of the same moles, which means that both are equally participating in the formation of the carbon dioxide. So we can take any one of these two gases to find the moles of any of the carbon dioxide and N2. Since uh, both carbon monoxide and carbon dioxide, they are present by 2 moles. We now calculate the moles of the carbon dioxide and the moles of the nitrogen. Looking here in this chemical equation, there are 2 moles of CO and 2 moles of CO2. Either take the comparison between carbon monoxide and carbon dioxide or NO with CO2, both are same, which means the same amount of the moles will be produced for the carbon dioxide, 0.5 moles. However, for nitrogen molecule, it is 1 mole here, and both reactors are by 2 moles. So for this purpose, we have to take the ratio. If it is 0.25 moles for NO, then how much moles should be there for N2, that is X, and we know for NO there are 2 moles and for N2 it is 1 mole. So X value will become 0.25 divided by 2, that gives us 0.25 divided by 2 is equal to 0.125. So basically the moles present for nitrogen are 0.125. Now we have calculated the number of moles of the product gases. That's what we had to do. Find the uh, product gases. So now add them together since both of them are products. So 0.25 plus 0.125 gives 0.375 moles. Now convert them into the volume. Since the reaction is being carried out at room condition, which means for 1 mole the volume is 24 dm cube. So multiply these moles with the 24 dm cube. This will give you 9 dm cube. So the right answer is option C. Then question number 24. Three statements about ammonia molecules and ammonium ions are given. Aqueous solution ammonia. In aqueous solution, ammonia molecules form coordinate. So here it says ammonia molecule form coordinate bonds with the hydroxide ions. For this purpose, we must have the structure of the ammonium hydroxide. Ammonium hydroxide is written as NH4OH. Now here NH4 is NH4 plus and OH is negative. So the bonding between NH4 and OH is not coordinate bonds. Instead, it is the ionic bond because we have ions present. Whereas coordinate bond is the one in which one atom share both of its electrons to form the covalent bond with the other atom. So A one is incorrect. Number two, ammonium ions are Bronsted Lowry acids. So NH4 plus means whenever it will react with any other species, suppose with a base, it would have to lose its hydrogen ion. It will lose its hydrogen ion and will become NH3 and hydrogen ion. Now the formation of the hydrogen ion is basically the property of an acid. Losing hydrogen ion is a property of an acid. So that's how this two is correct. Number three, the HNH bond angle is larger in the ammonium ion than in the ammonia molecule. Okay, bond angle. Ammonium ion structure is given, and we can see here that the it is of the tetrahedral structure, and within tetrahedral structure the angle is 109.5 degree. I can write the structure here. This is the structure of the ammonium ion, and plus sign. So 109.5 degree. Whereas for ammonia, we have seen that its angle is basically 107 degree. So yes, the angle in ammonium is larger than ammonia molecule. So that is correct. So both options 2 and 3 are correct, which means the right answer is option C. Then question number 25. From here onwards, the organic chemistry starts. The reaction says the steam is reacting with the sulfuric acid. The steam is reacting with the ethene for the formation of sulfuric acid. In the presence of sulfuric acid, and we can see the formation is of the ethanol. Which type of reaction is this? Okay, so if we say it is acid base, then we do not see any acid or any base. So this is incorrect. Addition, yes, it is addition because there are two reactants and the product is one. So adding two or three reactants together will give single product is a kind of the addition reaction, and this is an addition. We can also expand this equation. Carbon carbon double bond has this structure, ethene has this structure, and when water adds into it, then H will add over here, and one of the carbon, and OH will be added over here, and this single bond will convert, a double bond will convert to a single bond. So that's why it is a addition reaction. Then question number 26. Compound Z has a molecular formula C4H8O2. This is formula, molecular formula. Compound Z reacts with the propane 1-ol in the presence of the concentrated sulfuric acid, and we are given a skeletal formula of the compound St and U. What are the possible skeletal formula products of the reaction between compound Z and propane 1-ol? So basically, we can see here that all of these are representing the ester functional group. All of them are ester, which means the reaction is between the alcohol and a kind of the carboxylic acid. This must indicate the formula of the carboxylic acid. That's why we are getting the ester. So which uh, carboxylic acid which carboxylic acid must it be? We can count the carbon atoms. There are 4 carbon atoms, and the functional group is present at the terminal. So in total, there are 4 carbon atoms in the carboxylic part. And from the propane 1-ol, if we write its structure, it is C, 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 and OH. So there are 3 carbon atoms in the alcoholic part, which means we can easily identify the ester from here. As we know that the carboxylic part is present in the ester which is bonded with the carbonyl group. So there must be 4 carbon atoms. So 4 carbon atoms should be there. So we have 1, 2, 3. So which means this is incorrect. 1, 2, 3, 4. It must be correct. 1, 2, 3, 4. It is also correct. This part is correct in T and U. So S is definitely incorrect. Now about the alcoholic part, we have three carbon atoms in the alcoholic part. So let's count. Although there were 3 carbon atoms in this structure, 1, 2, 3, but this has incorrect carboxylic part. So 1, 2, 3, there are 3 carbon atoms this side, but 1, 2, 3, 4, there are 4 carbon atoms in this side. It is incorrect. So the only right option is T, ester. So T is the right answer of this question. Question number 27, and this question is a repeated question. Geraniol and nerol are isomers of each other, and we have to tell what kind of isomer is existing between them. So looking carefully to both the structure, we can see that This part is similar in both of them. This portion is similar in both of them. However, the other part is different. This portion and this portion are different in both of them. So what's the difference between here? We can see that CH is basically rotated clockwise. It is rotated, which means and how they are rotated because of the presence of the double bond here. There's a double bond. So rotation, the molecules can give cis trans on carbon-carbon double bond point. So we can have the cis trans isomer formation over here. Although all the groups are different here, we do not see similar groups on any of the carbon atoms, but even then, because of the presence of the carbon-carbon double bond, they are rotated. So this indicates a kind of the cis trans isomer. So the right option becomes B option. Then question number 28: which compound has the greatest number of stereoisomers? So we have to tell largest number of stereoisomers, and be mindful that stereoisomers contain both types, cis trans plus optical. So we have to consider both type of the isomers here. Let's start from the molecule A. I'm going to write the structures of A. A is 2-methyl hextuene. So I will write simple structure for this compound. This is first I will draw 6 carbon atoms in sequence. Now on position number 2 I should have methyl group, and then there is double bond also on the same position number 2. So this is a simple structure. Now here if we consider the cis trans, then there is no cis trans here. Why? Because this carbon is bonded with 2 methyl groups. Because of this reason, there is no cis trans. So in front of that, I will write cis trans is 0, no cis trans, and optical. For optical, we should have one carbon having 4 different groups, but there is no single carbon which contains 4 different atoms or group of atoms. So optical is also 0. So there is no isomer of this compound, no stereoisomer. Let's go with the molecule B. Again, it is 3-methyl hextuene, which means I have to link 6 carbon atoms first. After that, at position number 3, we have methyl group. So methyl group here, and then double bond at position number 2. Now let's check the presence of cis trans. So cis trans is present over here. How is it present? Because uh, we have methyl groups on both the carbons, this methyl group and this methyl group. Now if they are on the same side, this will give us cis form, and if they are on the opposite side of the carbon-carbon double bond, it will give you trans. So because of this, it can give you cis trans isomer. So cis trans isomers are together 2. What about optical? We do not see any carbon containing 4 different atoms or group of atoms. So optical is 0. Then compound C, 4-methyl. So again, for option C, I will again link 6 carbon atoms. So after that, we must have methyl on the 4th position, methyl group over here, and double bond on position number 2. So over here. Now in this case, 4-methyl hextuene. So in this case, cis trans, if we look for the cis trans of isomers, so there is a methyl group over here, and then there is a complete alkyl chain over here, and one hydrogen is present over here, and one hydrogen is present over here. So this molecule can give you cis trans isomer. So that's why cis trans isomer exists here. So there are total two. And what about optical? We can find one carbon over here. Uh, the structure is slightly different here. I have to draw the structure for the 4 methyl. So this is the structure of the C option. It is 4 methyl. Now over here we can again say the cis trans is present. Methyl group is present on left carbon, and this whole group is present on the right carbon, and hydrogen are present. So that's why cis trans isomer exists here. And about the optical isomer, then there is one carbon which has different groups present. This is methyl group, this is ethyl group, this whole is another type of the group, and one hydrogen is present over here, which means this carbon contains optical part, optical center, or asymmetric center. So that's why there are two optical isomers. For every chiral center, there are two optical isomers. So in total we have four. Now about the last compound, D compound. It is again sequence of 6 carbon atoms over here. Uh, there is double bond position number 2, and there is methyl on position number 5. Now here the cis trans does exist because methyl group is present here, and whole part over here, and hydrogen over here, hydrogen over here. So cis trans is there. But about optical, we do not see any single carbon which contains 4 different groups here. We do not have any single carbon, so optical is 0. Optical isomers are 0. So there is only one isomer which has the highest number of the isomers, stereoisomers. So the option number C is a right answer. Question number 29 is a repeated question. Vitamin A contains retinol, and this is the structure of the retinol. Under appropriate conditions, acidified KMNO4 can be used to break carbon-carbon double bonds. After these bonds have broken, further oxidation of fragment may occur. What condition used, and what do the final products include? So they have said that acidified KMNO is required to break the carbon-carbon double bond. So which conditions are required for this type of the reaction? We know we require hot concentrated KMNO4 here. If we use cold dilute KMNO4, then it will give you the alcohols. So hydrolysis occur in this case. But we are looking for the breaking of the bond. So option C and D are correct. But which product will be formed in case of in as a result of this reaction? So we should know a simple picture of the breaking and then reaction with the KMNO4. If we have this type of the bonding in the structure, then it will give you aldehyde first. How? This will convert into the, it will first convert into this form, and this is aldehyde part, and after further reaction with KMNO4, it will convert into the carboxylic part. So aldehyde converts into carboxylic acid, and if we have this type of the part in the compound, it will convert into the ketone. So we can have ketone. So wherever we have the aldehyde part, let's suppose if it is H here, we have H here, we have H here, all these parts will convert into the aldehyde first and then into the carboxylic acids. So we cannot get aldehyde here. We can only get ketones. Along with the carboxylic acid, we can only get ketones. So the only right option here is the option D. So D is the right answer. 30 question is also repeated question. What are the number of moles of carbon dioxide and water produced? So for this purpose, we must show a reaction in which this compound limonene is reacting with the oxygen. We know this is a hydrocarbon compound, a CH type of the compound, which is reacting with the oxygen to make carbon dioxide plus water, but we do not know how many moles are there. So which means we need to count the number of carbons and hydrogens present in it. So let's start with the carbon first. I'm going to label carbon atoms here: 1, 2, 3, 4, 5, 6, 7, and then we have 8, 9, and 10. We have 10 carbon atoms here. Now we check the number of hydrogen atoms. So there are 3 hydrogen atoms here, 3, and then we have no hydrogen at position number 2. But there is 1 hydrogen at position number 3, so it will become 4 hydrogen total. Then 2 over here, it will become 6, and we have 2 at position number 6, so it becomes 8. At position 7, there are another 2 atoms of hydrogen, so 10. At position number 5, we have just 1 hydrogen atom, so 11. And position number 8 has no hydrogen, whereas on position number 9 has 2 atoms, so 11 plus 2 will give 13. And at position number 9 there are 3 hydrogen atoms, so in total there are 16. So we can now we can now tell that the molecular formula of this compound, it has 10 carbon atoms and 16 hydrogen atoms, which means it is C10 and H16. So this is the formula. We now react it with the oxygen, and as a result carbon dioxide plus water will be formed. Now we simply have to balance them. To balance carbon, we write 10 over here. To balance hydrogen, we will write 8 here. Now the equation is balanced. So if we check the options, then we do not see any option of 10 carbon and 8 hydrogen of 10 carbons, which indicates that this equation must be simplified. So we can divide it by 2 and also divide 8 by 2. So if we do that, we get 5 carbon dioxide and we get 4 high water molecules. So 5 carbon dioxide and 4 water molecules. So option number B is the right answer. Then question number 31 is also repeated. The reaction of the chlorine with methane is carried out in the presence of light. What is the function of the light? This question is taken from a very old paper, 2004. Okay, so what's the purpose of using the light? We know the reaction is covered in 3 steps: the initiation, propagation, and termination. So the initiation step means breaking a molecule into 2 free radicals. We get 2 free radicals during the initiation reaction. So that is done in the presence of the UV light of sunlight. You can either write UV light or just sunlight. So option B is the right answer to break the chlorine molecules into its atoms. Chlorine free radicals are basically the atoms. They are not ions, and it is not used to heat the mixture, and they are not used to break the CH bonds, because CH bonds are broken by free radicals. Then question number 32. When X is added to NOH and heated under reflux, pentane 2ol is made. Which organic product is made when X is heated with solution of KCN dissolved in ethanol? Okay, so what we can expect here, that the compound pentane 2-ol was produced. The structure of pentane 2-ol is like this. I have to draw the skeletal formula for here, since all the options are in skeletal formula. So this is pentane 2-ol 1, 2, 3, or you can go from right to left 1, 2, 3, 4, 5. So position number 2 contains OH group. Now this must be obtained from compound X. Now which compound must be here, which must have some kind of group present on the same point? It should be some group present over here that must be converted into the OH. So it means that at same position number 2, let's see which can give us position number 2. This is position number 2, this is position number 2, the rest are not correct. So but in B we have 4 carbon atoms, 1, 2, 3, 4. That is incorrect because we need to have 5 carbon atoms, a chain with the 5 carbon atoms. So that's the right chain in option D, and CN is present option on position number 2. So D is the right answer. Question number 3. 1-chlorbutane and 1-iodobutane are both react with aqueous sodium hydroxide by the nucleophilic substitution reaction. Which reaction has the greatest number rate under the same condition, and which mechanism is followed by this reaction? Okay, so we can see that both of these two are basically the primary halogenalkane. Both of them are primary halogenalkane. So primary halogenalkanes, they give a mechanism of SN2 because two molecules are present in the rate determining step. So that's why primary, I will write primary halogenalkane gives SN2 reaction. They give SN2 reaction like this. We write like this, SN2 reaction. So this is correct. Now, which will give the greatest rate? Which means we have to consider the bond between the halogen and the carbon, because the halogen is substituted by the other. Sorry, the nucleophile is substituted by the other nucleophile. So in case of chlorine and versus CEI, we know down the group the iodine has a larger size, whereas chlorine has slightly smaller size. So the bonding between CI is weaker. CI bond is weaker because of the greater size of the iodine, and that is the reason that it can easily be removed and a new nucleophile can be attached with a carbon. So weak bond gives faster rate of reaction in case of the iodine. So iodobutane will give the faster rate of reaction. So the right option is D option. Then question number 34. Compound Y reacts with alkaline I2. When the product of this reaction are acidified, a dicarboxylic acid is produced. The formula of dicarboxylic acid is given, where R consists of 1 or more CH2 Which compound is Y? So we have to consider all of these are alcohols, which means we should know that which kind of alcohols can give the reaction with iodine. This is called Idoform test. Try idomethane, Idoform test reaction, which gives us CHIT I3, which is called triidomethane. So triidomethane is produced in this case, which has a yellow observed color. Now the alcohols which can give this type of reaction must have this group present in its alcohol, C, OH and H. This part must be present in the alcohol, only then this reaction will be possible. Which means we must first write all these formulas into the structure formula so that we can recognize that this part must be present in the given alcohols. So for option A, I'm going to write the the structure formula. It is C. We have 5 carbon atoms, so 2, 3, 4, 5, and then on position number 1 and 4, the alcohol groups are present. No. Uh, if we match this part with this given structure, we can see that the the right carbon will give the idoform test. This part will give the idoform test, but this one will not give the idoform test. Now, if this right part gives the idoform test, then this part should convert into the carboxylic acid, but not the left part, since the reaction is not carried out. So option A is incorrect because we are not getting this type of the product as a result of the further reaction. We must have carboxylic acid on both sides. That is not possible in case of option A. Now about option B, again we have to draw the structural formula. We have 5 carbon atoms again. Now they are saying at position number 1 and 5 are OH. Now, if we compare with this formula, it will not give us a structure. It will not give us the reaction because it doesn't match with this part. So, reaction is not possible in B. Then we go with option C. Option C says pentane 2,3-diol. So 3, 5 carbon atoms, and on position number 2 and 3, OH over here and OH over here. So basically we should have a carbon chain. Uh, we should have a carbon chain after this carbon over here, but it is again an alcohol over here, which means it is not possible to give a product containing two carboxylic acids on the two ends. This might give the carboxylic acid, but this will not be able to give the carboxylic acid. So that's why option C is incorrect. Then last one, the structure of D is carbon. We have 5 carbon atoms again, and then we have alcohols on position number 2 and 4 like this. Now if we compare here, we have exactly same structures on both sides. So both of them can give the carboxylic acids, and we know that uh, there must be formation of the carboxylic acids. At this point, these two carbons will come out for the formation of CHI3, and this part will convert into the carboxylic acid. Same goes for here. This part will convert into carboxylic acid, and the central part, there will be just one carbon atom, and we said that there can be one or more CH2 groups at the center. R is basically one CH2 in our case. So that's why this is the right option. D is the right answer. Then question number 35. Which alcohol gives one possible oxidation product when warmed with dilute acidified potassium dichromate? So it is an oxidizing agent. So which means we can understand only one product from these given compounds. Butane 1, for this purpose we must have the structure, simple structure. So butane 1 all is like this, and when it reacts with the potassium dichromate acidified, so it will first convert into the aldehyde. This is the first product, and upon further reaction it will convert into the carboxylic acid. So we can see that there will be two products here, 1 and 2. is no one product here. In option B, it says butane 2-ol, which means OH must be present carbon number 2. So when it reacts with the oxidizing agent, potassium dichromate, it must convert into the ketone. And ketone cannot further oxidize. So there is only one product here. Same goes for the 2-methylpropane 1-ol. 2-methylpropane 1-ol. If I write the structure, simple structure, we have methyl on second carbon and OH on the first carbon. So it will convert into aldehyde, and further upon reaction it will convert into the carboxylic acid. So again we have two products here, 1 and 2, and 2-methylpropane 2-ol. See, it has written like this. We have carbon atoms like this, OH. Now this is a tertiary alcohol. So this tertiary alcohol cannot oxidize with the dilute. So no product will be formed. So the only option with only one product formed is ketone in option B. B is the right answer. The question number 36. Which compound on reaction with hydrogen cyanide produces compound with a chiral center? So we have to find the one which contains chiral center here. So all of them must be reacted with the with the hydrogen cyanide. HCN must be reacted with all of them, and the products must contain the chiral center. So I will first react op- uh, with the option A. So when it reacts with HCN, the aldehyde part will convert into the alcoholic part. So the product will be like this: CH3, COH, H over here, and CN. So we can see here that this carbon has four groups: CH3, CN group, OH group, and a hydrogen. So which means there is a chiral center here. So chiral center is present in option A. So that must be the right answer. But we can confirm with the other parts as well. With the B, I will have this part CH3, CH2, COH, CH2, CH3, and CN. So on this carbon we have two ethyl groups on left and right. So it cannot give chiral center. It doesn't have chiral center. And option C doesn't give reaction because it is an ester compound. So ester do not give reaction with HCN. So no reaction possible. And option D gives this product. And this carbon doesn't have any chiral center. So the right option is only B option, is only A option. In question number 7, question 37, the diagram shows three reactions of ethanol. In each case, an excess of ethanol is used. We have these reactions. Observations are made after each of these reactions. What are the color solution 1, 2, and 3? Okay, whenever the acidified K2 reacts, then the color changes from from orange to green. This compound has an orange color, and the product will have chromium plus 3, which is a green color compound. So 1 and A and B from solution A. Now about the solution 2, it is a reaction between ethanol and I2. So we know triiodomethane is formed just like in previous question, and its color is yellow. And solid 3 is Fehling solution. So Fehling solution converts into red color. So red is the right answer from solid 3. So the only right option in this case becomes B. Question number 38. CH3 three times CCN. So which row names the molecules X and the class of alcohol Y? Okay, here we have the reaction of this compound with the hydrogen ions, and that will further react with lithium aluminum hydride. So when we react the compound, when we react them, then the reaction as a result of this hydrogen ion, we get this compound CH3, C, CH3, CH3, and then this CN part will convert into the carboxylic part. So COOH. Now we have uh, dimethyl propanoic acid present here. We say because there are three carbon atoms here, so it should be propane part. So dimethyl propanoic acid is there, and this compound will further react with lithium aluminum hydride LiAlH4, and this will convert into the alcohol. So the alcohol part is the one over here which will convert into the OH. So we will have similar structure, but instead of carboxylic acid we will have OH. Now you can see that this OH is bonded to a carbon. Sorry, O this whole COOH part will convert into the CH2OH part. This is a reaction. So instead of OH we write CH2OH. This is how the reaction occurs. The COOH part will convert to CH2OH. So the alcohol is bonded with only one carbon, which is bonded with further one carbon. So this is the case of the primary alcohol. This carbon is bonded with only one carbon over here, which has OH part on it. So primary alcohol is present there. So the option C is the right answer. My question number 39. Now this is our next question. Question number 39. The diagram shows a section of an addition polymer. The polymer is made using two different polymers. What are the names of the two monomers needed to make this polymer? So basically in this question we are supposed to find out two sections of monomers, or we can say that two different monomers must be identified in this whole polymer molecule. So how can we check that which two monomers are present here? We must check the structure here. What I can see here in the structure, that we have some repetition. For example, you can see that chlorine is present on this carbon, chlorine is present on this carbon, and then in the next carbon there is chlorine. So three carbon atoms are in consecutive way. After that we can again have three chlorine atoms in the consecutive way, and then methyl groups. You can also see the methyl groups present on this point, which indicates that there is some repetition. Now the next is that you have to uh, dissect them, or you have to take out the parts which are basically different here. Now if I see that this chlorine and this chlorine is present on this chain, the chain of the chain of three carbon atoms, I have these two chlorines present on this carbon chain, and the next part is basically a chain of four carbon atoms. So four carbon atoms are present on this chain, and this part has also chlorine atoms bonded on it over here. So the same structure will be seen in the subsequent order. This chain is present over here, and this chain is present on the next carbon. So these are being repeated, which means we have now figured out the actual monomers present here. So these are the monomers present here. We just have to now check out their names from the given options. The given options for the first monomer, we can see here that we have the chlorines on the carbon number 2 and carbon number 3. We have chlorine on carbon number 1 and 2, sorry, because we have to start numbering from the end, which gives smaller number. So 1 and 2. So 1 is present here, and 2 is present here, and 3 is here. So position 1, 2 contains 2 chlorine atoms, which means options A and C has this part of the monomer. 1,2-dichloropropene and 1,2-dichloropropene. Now, about the second monomer, we can see that they are 4 carbon atoms, so which means our monomer must should contain 4 carbon atoms. So but over here is there and but is there. Now, the name of this compound or this monomer is 123 or 123. We will start from numbering from here because this gives smaller number to the chlorine. So on number 2 we have chlorine bond on it. That's why 2-chloro but is there. 2-chloro, and this ene part is the one which is basically connecting two monomers. On since it is a polymer in which the double bond has already been broken down into a single bond. That's why we have the double bond present on carbon number 2. So 2 chlorobutene is the right name. So considering here we have 2 ticks on option number A, so A is the right answer. Then we have the last question of this paper, question number 40, and this is a question from analytical chemistry. We have the mass spectrograph, the mass spectrum given here, and we have peaks here. Then we have some statements given at the bottom. We have to check the right options, the right statements. The option 1 says that relative atomic mass of chlorine can be calculated from the abundances and the ME values of 2 of the peaks. So a relative, so yes, we can calculate the relative atomic mass of the chlorine. As we know, it should AR of the chlorine must be calculated from the percentage abundances of both the chlorine atoms, sorry, the chlorine isotopes, that is chlorine 35 and chlorine 37, and the ME values. So ME values are given here. It is 35 over here and it's 37 over here along with the percentage abundances. So option 1 is correct. Then option 2, 37 gram of the 37 gram of the species responsible peak Z contains 3.011 into 10 to the power 23 molecules, which means we have to calculate this point. So 37 gram of the peak Z, which means that the peak Z is basically the one which has a mass of 72, since we know that we have 35, peak of 35 and peak of 37, and this Z belongs to a peak of 37 and 37. Both isotopes are of 37 each. So the mass is 72 over here. Now we have to calculate the mole of this value. 37 plus 37 gives 74 gram. Now convert this mass into the moles. So the moles will become 37 divided by 74. This gives 0.5 moles. We now multiply this 0.5 mole with the number of particles of Avogadro's number, which is Na, and if you calculate it, 6.02 into 10 to the power 23. So the answer will come out to be 3.011 into 10 to the power 23. So that's the right answer. So 2 is also correct. Now option 3, the relative molecular mass of chlorine can be calculated from the abundances and the ME values of peaks X, Y, and Z. So they are asking, can we calculate the molecular mass of chlorine, which means Cl2, from the abundances given and the ME values of the peaks X, Y, and Z. So we have the peaks given, and it is 100%. This one is 60% almost, and this one is 10%. So from these values we can find the mass of the chlorine, and we are also given the Me values at the bottom at on the x-axis. So yes, we can find the relative molecular mass of the chlorine from the abundances and from the M by E values given here. We should know that Cl2 of 35 35 should be 71, Cl2 of the 35 37 is 72, and chlorine molecule of 37 is 74. So sorry, it is 73. So basically we can find it is 70 and then 72, 70, 72 and 74. This is like this. We have 70, 72 and then 74. So yes, we can find this as well. So in this way, third option is also right one, which means all the options are correct. So A is the right answer. Okay, students, I have solved this paper of October number 24, variant paper 11. I'll be uploading more papers of the same exam series of chemistry, AS, A2, and IGCSE, and O levels as well. If you have any queries, you can let me know in the comment section. Till then, take care and Allah Hafiz everyone.